and this is lesson 4.7, arithmetic sequences. And go ahead and put today's date, and by the end of the lesson, our target is that I can identify patterns and write sequences. Now to start this section off, we're going to look at some vocab. So some of our first vocabulary words are sequence. A sequence is a set of numbers in a specific order. Then we move on to terms. Terms are the numbers in the sequence. So an individual number is called a term. And then we move on to the arithmetic sequence. And it says the arithmetic sequence increases or decreases at a constant rate, called the common difference. So here's the big part to take away from the arithmetic sequence, is that it's going to increase or decrease at a constant rate. So that means it's going to keep that same value. It's going to keep increasing or keep decreasing at a constant rate. And that's our common difference. So if it's going to increase or decrease, that means we can only add or subtract an arithmetic sequence. So we can only add or subtract in the arithmetic sequence. And our very last one is our common difference. And common difference is the difference between the terms. So how far apart each is, how much you have to add or how much you have to subtract to get to the next term. All right, now that we have our vocab, let's go ahead and look at a couple of examples involving sequences. So our first example asks us to determine whether each sequence is arithmetic and to justify our answer. So this one is 1, 2, 4, and 8. And then ... shows it continues. So the easiest thing to do is to figure out the difference from each term to the next. So from 1 to 2, I add 1. From 2 to 4, I add 2. From 4 to 8, I add 4. So if you look across here, I'm adding 1, I'm adding 2, I'm adding 4. So it's not constant. It changes from 1, it changes to 2, then it changes to 4. So no. And when it says justify, it doesn't increase at a constant rate. All right, then we move on to our second example. And it gives us 1/2, 1/4, 0, and a negative 1/4. Sometimes when I do the fraction ones, I find it easier to find patterns when I get in a decimal form. So let's turn all these into decimals. So 1 divided by 2 is 0.5. 1 divided by 4 is 0.25. 0 is already 0, so I can't change him or get him into a decimal. He's a whole number. And our last one's a negative 1/4, so a negative 0.25. So then we're just going to look at here. We need to figure out how we get from 0.5 to 0.25. So we get there by subtracting 0.25. Then from 0.25 to 0, once again, I subtract 0.25. To get from 0 to a negative 2.5, I subtract, once again, 0.25. So I'm subtracting 0.25 each time, or we can go back and change it and say we're subtracting 1/4 each time. And because it's constant between all of these terms continuing on and on forever, that means yes. Because it increases, sorry, decreases, because we're going down, we're going from positive to negative, so it should say it decreases at a constant rate of 0.25 or 1/4, however you want to write it. So that was the first two, just determining if it was arithmetic. And like I said, it has to be a constant rate. So let's look at our third example. It says to find the next three terms in the arithmetic sequence 74, 67, 60, 53, and then ... to show it continues. So the easiest thing to do here is to subtract and say, what is 64 minus 67? That's going to give us 7. And then we say, well, what's 67 minus 60? Once again, we're subtracting 7. And how do you get from 60 to 53? Once again, you subtract 7. So once you know what you're decreasing by, then you know your sequence. So if we're supposed to find the next three terms, I'm going to make blank, blank, blank. There we go. And say 53 minus 7 will give us our next term of 46. And to find the next term, we'll do 46 minus 7. And 46 minus 7 gives us 39. And once again, we're going to do 39 minus 7. And that's going to give us 32. So our next three terms, our sequence, are 46, 39, and 32. And once again, you just find that constant rate that you're decreasing, you're increasing by, and then just continue the pattern. So once you kind of see how the arithmetic sequences work in that you're decreasing or increasing by a constant variable of like -7, then that's when we can start looking at it as a formula. So the arithmetic sequence formula to find the nth term. So our formula is A1 plus n minus 1 times d. So A stands for the first term of the sequence. Then n stands for the number of the term. So that means it's the first term or second term. And then d stands for the common difference. Okay. So let's look at how we can apply our formula to a example. So example 4, it asks us to find the 14th. So find the 14th term of, and then it gives us a sequence 9, 17, 25, 33. So I could feasibly find the pattern, add the pattern 11 more times and get the 14th term. But that would take a while. And because it's asked me to find such a higher term, this is when it's more successful to use our formula. It'll be a little bit quicker to use our formula. So I'm going to jot down our formula that we just got, and it's A1 and plus n minus 1 times d. Remember, we said A1 stood for our first term, n stood for our number that we want to find of term, and then d stands for our common difference. So A1, we know our first term here is 9. All right, n stands for the term I'm trying to find, and n's going to be 14. Now the last thing I need to find is D, and D's our common difference. So I have to figure out how far apart 9 and 17 are. So 9 is 8 away from 17, so I have to add 8. 9 plus 8 is 17. And 17 to 25, I add 8. And then 25 to 33, once again, I add 8. So my common difference is a positive 8. So now we just plug in everything that we know. A1 is 9 plus, and then I make our parentheses, n is 14, minus 1, times d is 8. So now order of operations says do our parentheses first. 14 minus 1 is 13. Drop down our 8. Now order of operations says I have to multiply, so 13 times 8. 9 plus 13 times 8 is 104. And 9 plus 104 gives us 113. So the 14th term in that sequence is 113. That saves us time and energy instead of having to add 11 more times to that sequence. And that finishes us up. Thank you very much, and have a good evening.